Hello, welcome to Chapter 10. Chapter 10 is all about parametric equations and polar coordinate. So in the first section, we're going to learn curve-defined parametric equation. So before I give you the definition, I want to show you in the graph what's the basic meaning of parametric equation and what's the parametric curve. So let's take a look at the graph of a function. So we have a function y equals fx, and for this graph function, we have graph and all the points given by x and y, right? Now we are going to change x into ft, y into gt. That means x, y given by two functions in terms of t, and we call the t parameter. And when t change, so you can see, given a t value, we can get x value, y value. That means given a t, we can find a point. So when t change, definitely x, y change, right? And in that case, we get a graph, and this graph is a function. And this curve is called the curve defined by parametric equations. Okay. Now I'm going to show you an example. Let's take a look at this. X is given by cosine t, y equals sine t, for example. This is called the parametric equation, actually. So you can see x and y both are in terms of t, right? And because we know identity, cosine squared plus sine squared, which is 1. So that means cosine squared is x squared, and y squared equals 1. So actually, this parametric equation gives us the curve. And what's the curve? Circle. Unit circle. X squared plus y squared equals 1. They are the same thing. Okay, so this is called the parametric equations. So here is just the basic idea. I'm going to give you the definition and then show you the example. What's the meaning of parametric equation and the parametric curve. Now let's take a look at the definition. Definition 1. Okay, so if x and y are given as functions, so the functions are like x equals ft, y equals gt, two functions both in terms of t, so over an interval I of t value. So the domain is the t value. Then the set of points. So all the points are given by x and y. So in this case, they are ft, gt, and defined by these equations is called a parametric curve. Equation is a parametric curve. And this equation are called the parametric equations for the curve. These equations are parametric equations. Okay, for the curve. So let's take a look at the example. In the example, I'm going to give you one parametric equation and then the parametric equations, and then we will sketch the graph. Okay, sketch the parametric curve. So let's see. Sketch the curve defined by this way. Okay, parametric equations. X equals t squared. This is ft. And y is given by t plus 1. And the domain for t So which is from negative infinity to infinity. So you can see this parametric equation, right? These are parametric equations. Now we want to sketch the graph. So we want to give some t value. We make a table. We give some t value, and then we calculate x value, y value, and then we plot x and y. And then let's see what's the graph going to be. So here we put t here and x, y. So we just give some special value to t. Usually we like to give just integers to make this easy. So you can choose any point you like. So let's do some easy point. 1, 2, 3. Let's see. And then we look at the parametric equation. X equals t squared. So you can see t equals negative 3 x t squared. So square of it. So 9, 4, 1, 0, 1, 4, 9. Right? Square of that. And y equals t plus 1. Negative 3 plus 1, negative 2. Negative 2 plus 1, negative 1. 0, 1, 2, 3, 4. T plus 1, y value, right? So right now we have x value and we have y value. And we can plot them. So here, how many points do we have? I think we have 7 points here, right? So let's take a look at the first point. It's 9, negative 2. So roughly, just don't need to be accurate. So if here's 4, here's 9, 8, here's 9. So 9, negative 2, about here. And 4, negative 1, about here. Okay, 4, negative 1. And 1, 0. 1, 0 should be here. And 1, 1, right? 1, 1. This is 1, 0. 1, 1 should be here. 1, 0, 0, 1. Next point, sorry. 0, 1. After 0, 1, that is 1, 2. So going to be 1, 2. And 4, 3. 4, 3. And then 9, 4. Roughly. Okay. And now we just connected those 7 points together. And let's see. It's going to give us a parabola. Right? Okay. So this curve is called the parametric curve given by these parametric equations. So that's the meaning of parametric equation and the parametric curve. Now let's take a look at example 2. Identify the curve. Identify geometrically the curve in example 1 by eliminating the parameter t and obtaining an algebraic equation in x and y. So let's take a look at the example 1. What's the parametric equations? So they are this. Alright, we want to eliminate t and just get the equation in terms of x and y. So I think if we look at those two equations, it's easy to solve t from the second one, right? So if we solve for t equals y minus 1. And then we plug into x. Plug into x equals t squared. Let's see what can we get. So we can get x equals y minus 1. This is like a substitution. Substitute the t by y minus 1. And this is the function we want to get. Algebraic equation, right? So this function is parabola. If we draw the graph, do you know how to sketch the graph? X equals y squared. That is this, right? So can do the dot line. Okay. And y minus 1, that means we shift this up 1 unit. Okay. So that graph is same as our example 1 graph. Now let's take a look at the exercise problem. Y equals 9t squared, and the same thing, t from negative infinity to infinity. This is number 1, and here's number 2. Y equals 2t. T from 0 to 1. Okay, I'm going to give you a solution next. So solve for t from here, from the first one, t equals x over 3. Plug in y equals 9 times t squared. So cancel the 3 squared, 9, we get x squared. So y equals x squared. The curve is given by this, okay? And this is the function we want. And the same thing for this one. For the second one, I think it's going to be line. Okay, so let's see. Solve for t from here. You can also solve for t from x. I think the second is easier. Plug into the first one. Y over 2. So going to be 3 minus 3 half y. So actually you can see this is a linear equation, right? Linear function. So this is a line equation. And because here, I didn't ask you to draw the graph, but be careful, t from 0 to 1 actually is not line, it is a line segment. Because it has end, 2 ends. If it's t from negative infinity to infinity, it's just going to be a line. Okay, you can see the difference, right? Depends on what's the t value. But here, you just need to know how to, cancel the t, find the function in terms of x and y. Next, let's take a look at example 3. Graph the parametric curves. So it's kind of same thing. We need to find the function in terms of x and y, and then sketch the graph. The first one, x equals cosine t, y equals sine t, t from 0 to 2 pi. Okay, 0 to 2 pi. So how to do this problem? It's hard to solve for t, right? There's no way to solve for t, but we know the identity t squared plus sin squared equals 1. So in this case, that means x squared plus y squared equals 1. So you can see this equation, there's no t. Okay, no t. And this is unit circle. Okay, the graph. So what's the meaning t from 0 to 2 pi? Actually, you can see when t is 0, what's the point? Cosine 0 and sine 0, right? So these are 1, 0. The point starts from here, actually. And when t equals move, it's going to move like this way, counterclockwise. And then when it goes to 2 pi, it will come back to the same point. So t equals 2 pi, same point. Okay. So if t from 0 to 2 pi, that means the particle, if we treat this as particle, is moved twice along the curve. Okay, t value. And here you can try this one. A cosine t, a sine t. Same thing, t from 0 to 2 pi. I will give you the solution later. There are two ways to solve this problem. I'm going to show you two methods. Okay, the first method, I like this one better. So I do x squared plus y squared, so which give me a squared cosine squared plus a squared sine squared t, and then I factor the a squared out as cosine squared plus sine squared. And by identity, cosine squared plus sine squared equals 1, so I get this one. So x squared plus y squared equals a squared. That means a circle with radius a, right? Circle with radius a. The other way we can do this way. We can solve for cosine t. So x over a, which is cosine t, and y over a is sine t, and then you use the identity sine squared plus cosine squared, which is 1, so we can get x over a squared plus y over a squared, which is 1. After simplify, so it's same as x squared plus y squared equals a squared. So you can choose either way you like. Okay. Now let's take a look at example 4. So example 4 means the position pxy of a particle. If we look at the point as a particle, the particle is moving in the plane, and given by the equations, the parametric equations here, x equals root t, y equals t, and the path traced by the particle, and the particle describe the motion. Okay, so now let's sketch the graph. So firstly, in order to sketch graph, we want to eliminate t and find the algebraic equation in terms of x and y, right? So same as before, you can see we plug the y equals t into x equals root t. You can do either way, there's no unique method to solve them. So I change the t into y. I think this is pretty straightforward. Root t, and which is just square root y. Right. And then square both sides, get x squared equals y. Oh, you can write down y equals x squared, parabola. And this parabola, if I sketch the graph, y equals x squared, so should be this one. Is that right? But be careful, look at our x. X equals square root of t, so that means x has to be positive, greater than 0. Okay, greater than 0. So in our graph, we don't have the left part. Left part means x is negative. So we don't have the left part. Our graph just has the right part. And when t goes, okay, something like this. If we look at this as particle moving along a path, so this is the path. Next, let's take a look at the exercise problem. So if we have parametric equations, x equals cosine t, y sine t, and t from 0 to pi. Okay, so we know this is unit circle, right? We did this a lot. X squared plus y squared equals 1, unit circle. But if we look at the t from 0 to pi, so actually it's the parametric curve, only the half top unit circle with radius 1. Okay, so 1 and -1. That's the exercise. Now let's take a look at the example 5. Okay, example 5, we are going to do backward. Given equation like in terms of x and y, we want to find the parametric equations. Let's take a look. Find parametric equations for the line through a point AB, okay, and having slope m. Okay. Actually, for given a slope for giving a point. We know the point slope equation. In calculus 1, we did this a lot, right? Point slope equation of the line. So that is given by y minus y naught. So I'm going to review this with you. Y minus y naught equals mx minus x naught. Okay, so this is the line equation with slope m past the point x naught, y naught. And here our point is AB, so y minus b equals m x minus a. So this is our line equation, right, firstly. And then there are several ways to do the parametric equation. You can make this thing equals t. There's no unique answer, so don't worry too much. So we just want to find some easy way. Okay, so this is one of the method. So if we let x minus a equals t, that means x equals t plus a, right? Because we just make x minus a equals t and solve for x. And then plug into our line equation. So y equals what? Y equals b plus m just times t. Okay? And in this case, because it's line from negative infinity to infinity. So 5. We can try the problem here. Find the line segment with endpoints. Endpoints are -1, 3, and just 3, -2. Okay. So we're going to do the similar thing, but firstly we have to set up a Cartesian equation for the line. For the line, we don't have slope here, but we can find the slope. Slope equals y2 minus y1 over x2 minus x1, which is -2 minus 3, -3 minus -1. So after simplify, -5 first. Okay, that's the slope. And then for the point slope equation, you can use any point between from those two. You can choose any one. Doesn't matter. So I'm going to just choose the first one. Okay, y minus 3 equals -5 first, x minus -1, so x plus 1. And the same thing, we make this equals t. Okay, so x equals -1 plus t, right? So y equals 3 minus 5 first t. Okay, that's the parametric equations for the line. But be careful, this is a line segment. Okay, line is from t from negative infinity to infinity because it can be infinity long. But line segment given endpoints, so we have to use the endpoints to find the boundary for t. T is not going to be infinity to infinity, negative infinity to infinity. It's going to be bounded by the endpoints. So we can just say, okay, because x equals -1 plus t. So if we look at x equals the endpoint, first endpoint, when x equals -1, what is t? T should be 0. Is that right? When we plug in, solve for t. Okay. When x is 3, what is t? So 3 plus 1 should be 4. So for the line segment, we should say this is parametric equations with t greater equal to 0, less equal to 4. That is the line segment. If I just ask you the line, you don't have to find the boundary for t. Okay, I think that's all we need to know.